anything from you, so just moving on to 5.7. So inverse trigonometric functions and differentiations. That's what we're going to do today. So develop properties of 6 inverse trigonometric functions. The 6 are the one that the famous one: sine, cosine, tangent, secant, cosecant, cotangent. That's what we're going to work on. Differentiate and inverse trigonometric functions and review the basic differentiation rules for elementary functions. So let's look at the inverse trigonometric functions. So none of the 6 basic trigonometric functions has an inverse function. You know that because when you look at the inverse function, when you look at the trigonometric function, for example, sine function looks like this. As you know, it keeps going. So if I want to look at the inverse, for example, right here, say pi over 2, that's equal to 1. So, and right here, which is 3 pi over 2, well, let's look at the 5 pi over 2, pi over 2, and negative 3 pi over 2. So you can see there's many of them. This is a pi over 2, comma 1. This is 5 pi over 2, comma 1. This is negative 3 pi over 2, comma 1. So if I want the inverse, as you can see, your y value is all 1 here. So I'm not so sure if I want the inverse. I don't know where this 1's supposed to go with the pi over 2, or 1's supposed to go to negative pi over 2 or 5 pi over 2. I have no idea. So if you want to look at the inverse trigonometric functions, you have to restrict your domain. Say, I only wanted to look at my sine to be only, say, if I would just look at this, only this domain. All right, if I just look at this domain, then yes, I have the inverse, because every value in here, okay, every value in x and y, they only have a 1x corresponding to 1 y values. Every 1 y values corresponding to 1 new x values. There's only 1-to-1 situation. So every one of us 1-to-1 situation. So remember that you can do the horizontal line test and vertical line test to figure out whether it is 1-to-1. So if I do vertical line test, there's only 1 point passed by. If I do horizontal line test, there's also only 1 point passed by. So you know it's a 1-to-1 function. So that is why if it's an inverse function, you want to look at it. Trigonometric functions, if you think about the inverse function of a trigonometric functions, you always have to restrict your domain so you can have a 1-to-1 function. So this is what you're going to look at it. So when you look at this, as you can see, every one of them, they have to tell you what domain they're looking at. They're saying sine of sine y equal to x. Each inverse function is arc sine y equal to arc sine x. But they will tell you the domain has to be negative 1-to-1, and range has to be pi over 2 to negative pi over 2, negative pi over 2 to pi over 2. So in other words, you're looking at your function. Remember, sine looks like this. This is what sine looks like. So you're going to flip that for the inverse. So inverse looks like this. So you're going to have pi over 2, you're going to have a 1. So it looks like that, right? So you can think of you drawing a picture inverse to that. Okay. So just think about this value. You have this, which is pi over 2, 1. And over here is negative pi over 2 and negative 1. So you get opposite. So you have over here, which is negative 1 comma negative pi over 2. And over here, which is 1 pi over 2. So as you can see, your x become your y because it's inverse. Your y become your what? X. So that's why it's inverse function. All right, so same over here, cosine y equal to x is r cosine. Whenever you see r, means inverse, okay, inverse of that function, inverse of the trigonometric function. So r cotangent is cotangent, arcsecant is secant, cosecant is secant. They all inverse to each other, okay? But make sure that you look at this, they are restricted domains and ranges, okay? It only works that restricted domain and ranges. If you look at entire domain and entire range, it does not work. It has to be restricted. That specific restricted domains, yes, it will work. It will have a inverse functions. So looking at this graph, they gave you inverse function, what it looks like. So this is what inverse arctangent looks like. I mean, arcsine looks like. This is what arc cosine looks like. This is arctangent, and this is arc cosecant. It's arc cosecant, and this is arcsecant, and this is arc cotangent. Okay, so look at those. So when you do your homework assignments, you can refer to this so you kind of understand what a graph looks like. So looking at the evaluate each function, so let's look at this. So it's an arcsine. So this is, let's look at this problem. Y equal to arc sine -1/2. So that is if and only if is what? Sine y is equal to -1/2. That's what that means, right? So remember, this is your x. So to be inverse means x and y would be what? Swiped. So y become a x become a y. That's what inverse means. So I would put, as you see, I would put y here is equal to what? It's x of this. Or then you're going to tell yourself, okay, sine y, sine of y, you can think of a sine of what theta give you -1/2. And you're going to say, oh, 1/2. That means if I draw my sine, then you're going to say this is a 1, that's a -1. So when do I get the 1/2? That is what? 30 degree? -30 which is -30 degree, which is what? Then you're going to say negative what? Pi over 6. So that's why you put the negative pi over 6. So you need to think about this, okay? So if you're not really familiar with the trigonometry functions, you just need to heavily rely on your calculator or Julia. So you're going to say arc sine -1/2, and you plug in this in your calculator, and will give you negative pi over 6. So you can just simply evaluate it, just put in your calculator. But you do have to understand the concept so you can do when they give you a variable, so you know how to find what is arcsine is, arc cosine is, or arctangent is. Okay? So as you know, the inverse means what? If I do composite this, f of f inverse will give you x. The same thing, f inverse of f will give you x, because when they're composite function, when you composite them, you get just x. You get this. You get just x. Okay. So properties of inverse trigonometric functions. If -1 less than equal to x and less than equal to 1, and y is between negative pi over 2 to pi over 2, then you know sine and arcsine, they inverse to each other, just become x. And arcsine and sine would just get what? Inverse to each other, just get a y. So in other words, they're telling you tangent and arctangent, they're inverse to each other. And arctangent and tangent, they're inverse to each other. So you're just left with whatever this argument is. So looking at this, they'll say, find this arctangent 2x minus 3 equal to pi over 4. But this kind of problem, as you can see, you cannot just plug it into your calculator because your calculator does not know what x is. So this case, you need to apply inverse properties. So I say I'm going to put tangent in the front. And you can see tangent and arctangent can cancel out because they're inverse to each other. So you're left with the 2x minus 3 equal to 1, and you're going to add 3 to each side. So then you get 2x equal to 4, then x equal to 2. All right, so you got it. So it apply that. So next one, derivative of inverse trigonometric functions. So I will not drive this, but I want you to, if you want to drive it, we can drive it, but you can, at least you can memorize it or refer to it so you can do your homework problem. So you can think of as, you can use this as a pattern recognition if you want to, okay? So looking at this is what you know. So inverse functions. So this is what you have. So whenever you have arc sine, all right, arc sine of u, you're gonna do square root of 1 minus u squared and then do the u prime right there. All right, so arc cosine is exactly like a sine, but you're gonna have a negative sign in the front. Whenever your trigonometric function starts with a c, like a cosine, cotangent, cosecant, they're all negative of the other function there. Okay, like an arctangent is a u prime divided by 1 plus u squared. So arctangent is the one that does not have a square root in the denominator. Okay, so arc sine has a square root of 1 minus u squared, and arc cosine is a square root of 1 minus u squared, and then over negative u prime. If it's a positive u prime, that's arc sine. If it's a negative u prime, that'd be an arc cosine. And arctangent is u prime divided by 1 plus u squared. Arc cotangent is negative u prime over 1 plus u squared. All right, now look at the arcsecant. Arcsecant is u prime over, look at this. You have one more thing here. Absolute value of u in the front, and then you're going to do u squared minus 1, not 1 minus u squared, but the u squared minus 1. So arc cosecant will be just like arcsecant, but you're going to have a negative in the front. Okay, so you need to kind of recognize this so you can do your problems. So if they give you this, it says find arc sine of 2x, then you want to say, okay, I need to recognize my u is 2x. So u prime would be just a 2. So just plug into your formula, then you get a 1 minus u squared, all right, which is 1 minus 4x squared, and u prime, which is just a 2. So just be done. Okay, so this 5.7 will be easy if you can recognize the patterns of their inverse functions derivatives. Okay, we'll just plug it into the derivative formula right here. Next one, you're gonna tell yourself again, for u in this case is a 3x, so u prime is 3. So plug back into my formula, and the formula says u prime will go what? 1 plus u squared. That's the formula. So I'm going to do 1 plus 3x squared, and u prime is of course 3. So you're done. Arcsecant of square root of x. So my u is square root of x. Or I can say x over 1/2. So u prime would be 1/2 times u. So negative 1/2. All right. So now you have that's equal to 1/2 square root of u. That's u prime. Okay, so let's do that then. So I will put, it says, the formula says u prime square absolute value of u, and then do what? The u square minus 1. That's the formula. Oh, I'm doing a sign. Excuse me, I'm doing a sign. So sine is square root of 1 minus u squared. All right, so u is this. So then what you u square then? U square would be what? Square root of x. The square would just give you x. That is why you just have x. All right, and now, so you have this as u prime, so you need to put it in here. So 1 over this, 1 over that, so which is right there. So you're done then. Okay, you can just stop right here if you want to. You don't have to go to this one if you don't want to. Okay, that'll be fine. Next one, arcsecant. Now it's secant. So my u is equal to e to the 2x. U prime is e to the 2x times 2. That's my u prime. So I'll put the u prime here. The formula says u and then square root of u squared minus 1. So what's my u squared means? E to the 2x, square that, which gives you e to the 4x squared. So you have e to the 4x squared minus 1 and divided by over 2. Okay, because this and that cancel out. So that's why you have that. All right, I just simply plug into the formula. That's what I just did. Okay, review of basic differentiation rules. So let's just go over the, let's just review this because you're going to take your final exams and you need to know regular algebraic functions and you need to know the transcendental functions. So what is algebraic functions? Like a polynomial functions, rational functions, functions involving radicals. Those are the algebraic functions that you just use regular power rules and product rules, quotient rules, and all that, okay, chain rules. And transcendental function is anything to the log or exponential functions or trigonometric functions or inverse trigonometric functions. Those are you call it transcendental functions. Okay, you just have two. It's just a name. Okay, you know the name, so you will recognize what it means. So whenever we talk about what is, take a derivative of transcendental functions, and you know you're talking about log, exponential functions, and trigonometric functions or inverse trigonometric functions. So there's more review. This is just a regular. This is your power rule. This is your power rule, and this is your product rule. This is constant rule, and this is a power rule. This is you just have to memorize this one. Remember, natural log is a special case, so you have to memorize. If it's natural log, it's 1 over u times u prime. So that's what you have here. And then, as you know, if you have a plus minus, you just take a derivative of each individual one. If it's a quotient, you gotta use the quotient rule. It's a power rule. If it's a okay, so this one, I am not so sure what it's doing here because they're talking about if it's absolute values, you need to make it into 2 parts. Okay, and then here, e to the x, just e to the x. Okay, derivative of e to the x is e to the x. Now they're going to do a log. You need to memorize this one. We have done this one already. Sine and tangent, secant, cosecant. We got all of this. Okay, so you need to print this one out. So when you take your exam, when you do your homework problem, you can refer to this. So this is a complete review. It shows everything about the derivatives of elementary functions and derivative of a log and exponential functions and trigonometric functions, inverse trigonometric functions. So it has everything. So all the 24 covers everything that we have learned about derivatives. All right, that's it. So anybody have any questions from homework problems or the lesson I just gave you? Anybody have any questions? Okay, as I said, this one, yes, you can just simply plug into your calculator. So if you want to reach arc cosecant, so you can think of, okay, first one, cosecant theta is the same as what? 1 over sine theta. So you need to do inverse of a sine, which is arcsecant. Okay, arcsecant, and then you can do, so 1 over arcsecant will give you, 1 over arcsine will give you secant, arcsecant theta. So you can plug that in your calculator. Okay. All right, same thing here. They're asking you to figure out what is this number should it be. When does it give you pi over 4? When y bar is pi over 4, what is this one? So in other words, they're asking you tangent theta equal to pi over 4. What is tangent should it be? I mean the arctangent, excuse me. Arctangent y is equal to pi over 4, then you're going to say, okay, what is tangent pi over 4 equal to? And pi over 4 would be what? Square root 2 over square root 2 would be 1. All right, so that's what we're going to do. Same thing here. All right, this one, I want you to look at this one. So this one is the one that I'm talking about. If they gave you variables, how would you do this? So first thing first, they're telling you, use the figure to write expression algebraic form y equal to r cosine theta. So they gave you y equal to r cosine theta. Well, let's look at what cosine theta means. Cosine theta means what? Adjacent over what? Hypotenuse. That's what that means. Okay, so you're gonna say, okay, so I have this. So I can say cosine y is equal to x over 1. Then can I figure this one out, what that equal to? Yes, because I can use Pythagorean theorem. Pythagorean theorem says 1 squared is equal to x squared plus, I don't know what this equal to, so I'm just call it opposite. Okay, it's opposite. So opposite square. So opposite square is equal to 1 square minus x squared. So opposite would be equal to 1 square root of 1 minus x squared. So I figured out opposite equal to 1 minus x squared. So if you want to find the tangent, okay, they're asking to find the tangent. So tangent means what? Tangent is equal to opposite over what? Adjacent. So opposite is this. Adjacent, what's adjacent? X. So we're done. So this is your answer. Okay, I want you to look at this one. This is the one that I'm trying to tell you. You need to understand the relationship. What is cosine related to tangent? What is tangent related to sine and things like that? Okay, you need to understand this. So they gave you this, and you're supposed to know this. Okay, you're supposed to know this Pythagorean theorem to figure out what this opposite is, and you're supposed to know what tangent is. Let's review. Sine theta is equal to what? Opposite over hypotenuse. Cosine theta is what? Adjacent over hypotenuse, and tangent theta is equal to what? Opposite over adjacent. Remember this. Okay, that's what we're gonna use. Okay, same here. They were asking you to do the same thing again. So you're gonna do okay. So you're gonna say okay. They gave you cosine again. So you got this, and we happen to know what this equal to. This is equal to 1 minus x squared. So cosecant, what cosecant means? Cosecant is the same as 1 over what? Is it 1 over sine? Okay, so 1 over sine is 1 minus x squared over 1. Remember, sine y is opposite over hypotenuse, which is opposite is 1 minus x squared, hypotenuse is 1. So that's what I plug it in right here. So when you do the multiplications, then you get 1 over just 1 minus x squared. That's what your answer is. All right, so you can do all these. Okay, there's another problem. This is good. Okay, so I mean, if you want to, you can find what this is in your calculator, but they are asking you not to use calculator because they want to make sure that you understand what that means. So in other words, you need to do this one. Watch r cosine square root of 2 over 2 is equal to a x. And you're going to say cosine what? I'm going to call it theta. Cosine theta is equal to square root of 2 over 2. So what is the square root of 2 over 2? Give you theta. So theta would be equal to pi over 4. All right, square root of 2 over 2 is pi over 2. So now I can plug it in. So I'm going to say, what is tangent pi over 4? Then you're going to say that is equal to 1. All right, so you do exactly the same thing for this. Same here. So you need to understand the relationship, then you can do this problem without any problem. Again, this is the same problem like that. You're going to apply tangent here, tangent here. Then you get 4x minus 8 is equal to tangent negative 1. Okay, and then you're going to say, okay, the 4x is equal to tangent negative 1 plus 8. So x is equal to divided by everything by 4, tangent negative 1 plus 8. So when you put the tangent negative 1 in your calculator, I guess it gives you some number. So when you multiply by together, so x is equal to this number, 1.611. Okay. All right, so this is a, now this is a derivative. Let's review this. So you're gonna say u is equal to 9t squared. So u prime would be equal to negative 18t. So now I'm gonna just plug into my formula. So it says derivative of arc cosecant would be equal to, since it's a cosecant, it'd be negative u prime over what? Square root of 1 minus u squared. So I'll just simply plug into my formula. Then it would be my u is this. So I'm gonna do, okay, u is this, what's u squared then? Negative 9t squared, which is equal to 81 t to the 4. So I have a 1 minus 81 t squared, t to the 4. And then u prime is this, negative 18t. So I'm done. So in a way, it's much easier because I don't have to do anything other than just plug into my formula. So if you recognize your patterns, this becomes a very easy problem. Okay. Oh, it's a cosecant. Sorry. What I just did is here is what? It's a cosine that I did. Sorry, I did a arc cosine, not an arc cosecant. So this is incorrect. Even though I wrote it down cosecant, but I was doing a cosine. All right, so derivative of cosecant u is equal to negative u prime square absolute value of u and then u squared minus 1. That is the formula. So we're going to do exactly the same thing the formula says. So we're going to plug it in. U prime, we got it right here, negative 18t. U, which is right here, negative 9t squared. U prime, the square root of u squared, which is this, 81 t to the 4, and minus 1. All right, so I can take the absolute value out. So I have a negative 18t, everything over 9t squared, and I have 81 t to the 4 minus 1. And I can cancel out 9 and that, you get a 2. And you get cancel out t, and you get 1. So you have 2 over t and everything over 81 t to the 4 minus 1. Okay, so what they did is here. So they want absolute value to be there, right? But what they did is they're going to leave this one to be there so they can cancel that out. And then you're going to have just a positive t. That's what they did. You see, when you look at their answer, they have a positive t. Okay, so that's how you got it. Because they want to make sure that t is always positive. That's what they want to do. So you do exactly the same way here. All right, any questions so far? Okay, this is your application problem. So they were asking you, they gave you this data. An airplane flies at an altitude of 5 miles toward a point directly over the observer. Consider theta and x is shown in the figure below. So you have this. So now write theta as a function of x. So they want you to write down, this is x right here. So they want to write down theta of x. What is that equal to? So I want to know, so I have x here and I have a 5 here. So what's the relationship here? So this is adjacent, and that's your opposite, right? In terms of your theta here. So what does it give you a, what is opposite over adjacent? So if I want to write down this, theta of x, I can say this is, so they wanted to write down in function respect to, okay, so let's think about that. So tangent theta will give you opposite over adjacent, which is equal to 5 over x. All right, so now, but they want you to write down this equation as theta equal to something, not tangent equal to, right? So I'm going to say, okay, then I need to apply arc tangent to each one of them. So I can say, okay, then I can say arc tangent theta okay, then that they cancel out. So this is a theta. So I have a theta of x equal to arctangent 5 of x. All right. Or you can rewrite it as theta x is equal to arctangent x over 5. They just like a function to be the x to be in the numerator. So that's why they wrote it like this. But this is the same answer. You can write down as arctangent 5 over x, or you can write down as arcotangent x over 5. All right, so now after that, the speed of the plane is this per hour, d theta and dt, and x equal to 8, x equal to 8, 3, round your answer to 3 decimals. So they want you to find a derivative of that. So when x equal to 8, what do? You just take a derivative over that. So d theta dt is equal to, so taking a derivative of this, all right, so you get what? U is equal to x over 5. So u prime is equal to 1/5, right? So I will take a cotangent, which is negative u prime everything over 1 plus u squared. So I can, which is the same as then negative 1/5 everything over 1 plus u, which is x over square of that. Okay, so when you multiply this one out, so you're going to put the 5 in the bottom. Right? Because it's negative 1 over 5. So you can do that. Or I can rewrite it as, but they like to put it as x squared to be the 1. So what they did is this. I want you to look at this, and they just need an algebraic expression. So you have, just look at this part, the denominator part. So 1 plus x over 5 squared is equal to 1 plus x squared over 25, right? But they were saying, okay, I don't want to have denominator. So what did they do is they multiply everything by 25ths. That means I got to multiply this by 25th. That's what they did, because 25 over 25 is still 1. So when you do that, then you get negative over 5 times 25, 25 times of that, which give you negative 5, and you have 25 plus x squared. So this is what you get over here. Okay. So now they were asking you dx dt would be negative 30, the number they gave you. Where's the number they gave you? dx dt is negative 394. Did they give you a number where this negative 394 came from? Oh, right here. Okay, so you have this, and x equal to 8. So you plug it in, x equal to 8 here. All right, so you just plug it in. dx dt came from here. They told you the plane of the 394 miles per hour. So that is dx dt, that part right here. All right, so you plug it in, the number they gave you, dx dt to be 394, theta x to be 8. Then you just plug it in to this formula over there, then you get this number, 22.1.35. So this is a little more complicated, so you need to make sure that you know how to do this problem. You may need to ask me again tomorrow if you choose to. All right, that's it. So anybody have any questions that you need to go over? Everybody good? Anybody have any questions? All right, so that's it for 5.7. So we got one more lesson left, 5.8, then we'll be done. So please do your homework problems, not just this chapter 5, but your review problems, so you'll be ready for your finals. All right, that's it for that. I don't have anything else. So if you don't have any questions, I'm gonna let you guys go, and I will see you tomorrow.